case she's not able to. Okay, so critical numbers again. What's the definition of a critical number? How about Tristan?
Can you hear me?
Yes, I can.
Oh,
Nice to hear
okay.
your voice.
It's a number C, right?
Yes.
So a prime f prime of C equals 0, or it does not exist.
Exactly. Yes. Okay. You can also just say it's a critical number is when the derivative is equal to 0 or it does not exist. Yes. Okay. So good. All right. So now notice right here, sorry, this is really small. I don't know why my notes made this really small. If f has a local max or min at that C, then obviously it is a critical number. Okay. All right. Okay. We are now going to talk about a method that gets used a lot. It is called the closed interval method, okay? And it actually comes from the extreme value theorem. Remember the extreme value theorem? We said if you have a closed interval and the function is continuous, okay, the function is continuous, then there has to be, okay, I'm actually going back to I make sure I say the correct thing, right? So again, if the function's continuous on the closed interval, then there has to be an absolute max or min somewhere, okay, on that interval. It could be on the, it could be anywhere in between the interval, or it could be on the end values, okay? So the closed interval method, we use this to find absolute max and mins. Okay, and again, it's by using the EVT, extreme value theorem. Okay, so what do we do? Okay, and again, we're talking about I should say we're finding absolute max and mins on a closed interval. Okay, if you do not have a closed interval, you can't use this. Okay, so it has to be a closed interval, and it also has to be continuous because we're using the EVT. Okay. All right, first thing we're going to do is find the critical numbers. So we're going to find the critical numbers on the open interval. Okay, so we're going to find all the critical numbers just on the open interval. Okay, and their values. Let me put that there, and values. Okay, so we're going to find all the critical numbers and their values. We are then going to find, and actually there's only 3 things, not 4 things, okay? We are then gonna find the value at the endpoints. Okay, so we're gonna find the critical numbers because again, critical number could be potential absolute max or mins, and then we're gonna check the endpoints, all right? And then the largest values, okay, the largest values, and sorry, I'm writing really bad, but that's values. Okay, largest values will obviously be the absolute max. Okay, and the smallest values will be the absolute min. Okay, all right. So let's look at an example or 2. Okay, so let's look at first example. So let's say I've got f of x is x cubed minus 3x squared plus 1. Okay, so first thing I'm going to do is I'm going to find the critical values. Now let me, I didn't give myself what is going to be the closed interval. So I'm going to say, so I'm trying to find absolute max and mins, and I'm going to put on the interval -1/2 and 4. Okay. Have your calculator handy as well, okay? It's kind of annoying. I have 2 calculators at my house. One of them, I can't find the charger for it, and it's like about to die. I hope it doesn't. And then the other one is out of batteries, and I haven't had a chance to go get new batteries, but I'm hoping this calculator won't die on me. But have your calculator handy, okay? Because we want to use it to find the values. Okay, so what are we going to do? We're going to first take the derivative. How about Jaden, could you take the derivative for us?
It would be 3x squared x to the power of 1, right?
So we need to take the derivative of the 3x squared. What's that going to be? This one right here.
This 6x.
So good, minus 6x. And then the derivative of plus 1?
0.
Fabulous. Okay. All right. Again, why am I taking the derivative? I'm finding those critical numbers. So first thing, I didn't state this, okay, but this is a polynomial. Therefore, it is continuous. Okay. We know it's continuous. So that's why we're using this. Okay. So I didn't state that, but I am stating it now. Okay. And I'll actually put that right over here. So it's a polynomial, therefore it is continuous. Okay. So, and then this is also a polynomial. So I know that it's defined for all real numbers. So, excuse me. So it's never going to not exist. So I just need to set it equal to 0. So let's do that. Let's set it equal to 0. 3x squared minus 6x. Okay. Just like before, I'm just going to times everything by a 3 just to get rid of it. Excuse me, not times, divide everything by a 3. So I'm going to end up having x squared minus 2x. Okay, let me factor out. Again, I'm factoring out the smallest factor, which is an x to the first. So that's going to be x times x minus 2. Okay, hopefully, right, everybody should be able to look at this. So it looks like x could either be 0, because 0 times a negative 2 is 0. So x is 0, or it's 2. Those are my critical numbers, okay, which tells me that those are possible local max and mins, okay? So what I'm going to do now is I'm just going to go ahead and make a table. This is my x, this is my f of x. Important to realize I'm finding I need to now find what are the values. So I'm going to start with, because I'm also going to check the endpoints, okay? So I'm going to put negative 1/2. I'm going to put 0, I'm going to put 2, and I'm going to put 4. Okay, those are what I'm checking. So this is where I'm going to now grab my calculator. Okay, so I'm going to grab my calculator. And like I said, hopefully, right, this is not going to die on me. I am going to go to y equals. I'm going to put in the original function, not the derivative. Okay, so be really careful with that. The original function was x to the third, x to the third minus 3x squared plus 1. Okay, so I've got it in my calculator. I'm going to hit second quit. I'm going to go to my home screen. I'm going to go to my vars. I'm going to go to my y variables. And I'm going to choose y sub 1 because that's where I put it in. Grouping symbol, and I'm going to put in negative 1/2, which is negative 0.5. So just negative 0.5 and hit enter. Okay, so that's 0.125. So I'm going to write that right here. Okay, I'm going to go back and hit second enter. So it copies it, and I'm going to change it to 0. Now I know I should be able to just look at it and see what 0 is, but I'm just going to, no, I can look at it and see, I know it's 0, it's 1. I can see that really clearly, but I'll just go ahead and do it. Okay, so second enter again, I'm going to put in 2. That's negative 3. Okay, so I have 1, negative 3, and then I'm going to do 4. So again, second enter. I got 17. Okay, so do not sit there and do that each time, okay, in your calculator, put it in the Y editor, because again, this is a timed test, okay, it's timed test. So you want to be able to find these very quickly. So use the calculator. Okay, so now that I'm looking at it, I can go ahead and see that this is the absolute max. Okay, so the absolute max is occurring on the endpoint, okay? And then the absolute min is right here. Okay. All right. How's everybody following me?
Yes.
Good so far.
Yes. Okay, good. All right, let's look at one more example and then I'm going to get you guys working. All right. So again, let's go ahead and find. So let's look at, we have f of x and it's going to be x minus 2 sine x. So again, we want to find absolute max and mins, and we're going to use the closed interval of 0 to 2 pi. Okay, so what is the first thing, Sergio? What do I want to do first?
The derivative of the function.
Exactly, okay? But even before I do that, I'm just going to take note, x minus 2 sine x. Okay, I know that sine x is also continuous and x is continuous, okay? So this is a continuous function and I can input anything, right? Like there's not any, I can put any number I want for x into that. So I know that it's continuous, and I also know that there isn't anything where it does not exist. Okay, so I only need to think about when it's going to equal to 0. So just take a moment and kind of think about that. So again, same thing. I'm just going to put here that it is continuous. Okay. Okay, so like Sergio said, we are going to take the derivative. How about Edgar? Could you tackle that for us?
Wouldn't be like, so the first one would be 1
Fabulous.
minus, what is it, cosine x?
Very
Or 2
good.
cosine x.
That's right, 2 cosine x. Okay. So again, guys, you want to make sure you want to get a little faster with those. Okay. So just those flashcards, I got to say, they really, really, really do help. Okay. All right. Let's set this baby equal to 0. Okay. So we're going to set it equal to 0. And I'm just going to bring this over to the other side. Okay, so I'm going to have 2 cosine x equals 1. I'm going to divide by 2. So I have cosine x equals 1/2. Okay, so let's think about our unit circle. When is cosine x equal to 1/2? Okay, so I'm going to go ahead and let me move this for a second. Let me grab another piece of paper. I'm just going to think about, okay, here's my unit circle. Okay, and I know that up here at pi over 2, right, it's 0, 1. Okay, and I know at pi over 4, it's root 2 over 2. So I have to think about when, as it's going up, I know that cosine is getting smaller, right? And I actually, if I look at it, I know right up here at pi over 3, okay, this is 1/2 and this is root 3 over 2. Okay, so at pi over 3, it is 1/2. Now, where else is it 1/2? Well, if I were to reflect this triangle on this side, cosine will be negative, right? Down here, it's negative. If I reflect it on this side, right? So if I go ahead and reflect it down here, it's also 1/2 at 5 pi over 3. Okay, so if you need to look at, if you got to look at a unit circle, that is fine. But again, you won't have that unit circle, okay, on the test. So you got to kind of be able to find those. All right, so let's go back. So it's at pi over 3. And of course, nobody asked this question right now, but of course you could have done maybe the inverse cosine and you would have gotten a decimal answer. But again, you want to be able to find both of those. And usually they're going to have the answer in a pi form, okay, not in a decimal form. So you got to be able to do it with the unit circle. Okay, so it's at pi over 3 or 5 pi over 3. Those are my critical numbers. So again, I'm going to now go ahead and make my table. So this is my x, this is my f of x. I'm going to start at 0 because 0 is the closed interval. And then the next one would be pi over 3, and then it would be 5 pi over 3, and then it would be 2 pi. Okay, so I'm going back to f of x. So again, I'm going to go to my calculator. I am going to put x minus okay, and also, I mean, you should be able to do this without a calculator too, but generally, a calculator is used on these problems. All right, so let me go back. Okay, so y sub 1, I'm going to find it at 0. No surprise, that is 0. Second enter, I'm putting in pi over 3. Okay, which is negative 0.6848. Again, I want to go out 3 decimal places. Okay, they want you to go out 3 decimal places. So that's actually negative 0.685. Okay, if I do the next one, which is 5 pi over 3, that is 6.97. Yes, 6.97, 0, but I'm going to just leave 0.7. And then 2 pi is, so again, second enter, put in 2 pi. We get 6.28. All right, so looking at that, what is my absolute maximum? This one just kind of barely beat it, right? But this is definitely the absolute max. Okay, this is the absolute, this is the value that's giving me, excuse me, this is the input that's giving me the value, which is the absolute max. Okay, so this is the actual max, let me go ahead and, okay, this is the absolute max value, it's 6.97. And then what is my absolute min value? It is right here. Okay. All right. Anybody question? This process right here is really not, I don't think it's too complicated. Where it starts to get complicated are the word problems, because this right here is kind of like, the nuts and bolts of it, but you're going to actually see when we start looking at these problems in relationship to the test, there's usually, it's always within the context of a story. Okay. But we'll talk about those a little bit later. But all right. So what I would like to do is have you guys start to practice some of these. Let me stop we never got Elizabeth back. Oh, all right. Well, if anyone's talking to Elizabeth, I don't know if anyone's, hopefully her internet went out, but I will definitely post this video so that she's able to see it. Because I know the internet's been really bad out in like the Point Reyes area, right? In West Marin. Yeah, it's been really bad. So I'm sorry that that's going on. Not like, it's like, do we need another, but anyway. All right, let me just show real quick so you guys can get working, okay, get practicing. So we are this week, and of course I haven't had a chance to look at your work yesterday, from, you turned it in yesterday. I will be looking at that probably today and tomorrow. Okay, oops, sorry, I clicked on the wrong one. Here we go. And sorry, Andre, I will actually re-add unit 4 here. I didn't do that, but it is right there, okay? But I will add it, okay? So there's going to be a related rates that's going to have maybe 3 or 4 more related rates problems, okay? I haven't put it on here yet. I'm going to, but I actually don't want you to start there anyway. I'd like you to start right here on page 304, okay? 35 through 45, you're just finding critical numbers, okay? And then these other problems, you're doing the closed interval method that I was just modeling for you, okay? So that's where I would like you to start, okay, on page 304. I am going to go ahead and put you guys in breakout rooms, but if you would like to see problem 30, I don't know if anybody would like to have me go over. That was the volume of, that was the cone problem where water was coming in and water was coming out. If anyone would like me to do that problem, please stay. If you feel like you got it, there's actually a lot of videos that are same type of problem. Maybe you already watched something or you talked to somebody, then that's fine too. Okay, but so up to you. All right, I will go ahead. And all right, Misiel, did you have a question for me?
No, I was working on a problem, so I got a little distracted.
Oh, okay. All right, how about Aiden? Yes?
I was just wondering if you could go over that cone problem again. 'Cause I kinda got tripped up on that.
Yes, let's look at it.
Cool.
Okay. And I'm just gonna, oops, let me grab a new piece of paper here. Oop. Where's the piece of paper? All right, okay. Oop. All right, how are you doing?
Good.
Aiden? You're doing all right?
Yeah.
I kind of missed, we haven't had the Brave time, so I haven't really
Yeah.
got to talk. I mean, in a way, I don't know about you. I know a lot of kids don't like it, but
Mhm.
I liked it.
Yeah.
I like it, but I don't know exactly. They're changing it a little bit. I'm not exactly sure what's going on with it.
Yeah, I was like confused the first week. I was worried I'd like missed it, but then I think Matt told me we just weren't having it.
Well, supposedly we are, but there were a lot of kids that, which I get. We want to listen to kids, right? Kids were saying, I don't really find this valuable, but then
Yeah.
other kids were. So we're trying to kind of retool it a little bit. But anyway, okay. So this problem says water is leaking out of an inverted conical tank. Okay. So that's the first thing I'm going to do is kind of draw. So an inverted cone is kind of like an ice cream cone, right?
Yeah.
Like that. Okay. So I'm going to go ahead and kind of draw that first. Okay. So water is leaking out. Okay. So maybe like, I'm going to just, maybe this is the water, and I'm just going to kind of, so water is leaking out. Okay. Not a good thing, right? To have anything leaking, but water's leaking out. And they give us at the rate. So anytime I see that, that's giving me the rate of change. That's giving me the derivative. So it is leaking out at a rate of 10,000 centimeters cubed. So that's dV, and I'm going to put out underneath it, okay, because they're talking about water going out. So maybe there's water going in, right? So that's the out dt, and that is 10,000 centimeters cubed per minute. Okay, and again, this is related to the change in the volume, change in time. All right, the next thing they say is at the same time, so water is leaking out at the same time that water is being pumped in. Okay, so water is also being pumped in. So, maybe there's a pipe right here and, water is coming in. And it says at a constant, okay, so at a constant rate, they don't tell us what that rate is. The tank has a height that's 6 meters and the diameter at the top is 4. Okay, so let's put this is 6. The diameter is 4. That means the radius is 2. Okay, all right. Now they say if the water level is rising, okay, so that means, so if the water level is rising, that tells me that the rate that the water is coming in is obviously a faster rate, correct? because otherwise
Yeah.
the water wouldn't be rising. Okay, not that I need to know that, but I mean, still. Okay, so the water level is rising at a rate. So, okay, so that's something else they're giving me. So they're giving me DHDT. And that is 20 centimeters per minute. So 20 centimeters per minute. And so if the water level is rising at a rate of 20 centimeters per minute, when the height of the water is 2 meters, so when the height of the water is 2 meters, that's where I'm stopping it. Find the rate at which water is being pumped into the tank. I know, very confusing problem, right? I
Yeah.
actually hated these problems when I was in high school. Like, oh my gosh, I hated these types of problems. We're like, but these are these are the types of problems. So, all right. And, we have to kind of solve it. So we are trying to find the rate of change of the volume coming in. So that's important to kind of realize. Okay. So I want to find dV, and I'm going to call it in over dt. And I want to find it at the exact moment when the height is 2 meters, correct? Is that what they said?
Yeah.
Yes, 2 meters. Okay. Okay, so the first thing I want to do, because I have to, and I'll be honest, the first time I did this problem, I made this mistake, is I want to kind of notice these rates are in centimeters. This is in meters. So I have to convert. Okay, I've got to convert. I'm not going to convert these because they're both in centimeters, but 2 meters would be 200 centimeters, right?
Yeah.
So I'm going to change that right now just so I don't make that mistake. That's 200 centimeters. Okay. Now, so I've read the problem. I've kind of got everything set up. I know what I need to find. Now I have to find the equation that relates all of these things. Okay. Well, that would be the volume of a cone, right? That would be the volume of a cone. But I have to be careful. So I'm going to write that down. So its volume is, it's 1/3 pi r squared times h. Okay. But I also want to be careful is that this isn't just one volume. Really, the total volume, it's the volume of the water coming in minus the volume of the water going out. Does that make sense?
Yeah.
Okay, so this isn't just V, it actually would be volume of in minus the volume of out. Because that's what it is. It's not, if they just said that the tank was filling up, then there would just be one volume, just be V, but we got two happening here. And that's 1/3 pi r squared h. Okay. Now, the next thing I want to look at this is if I started to take the derivative of this, notice right here, and we did an example like this right last week, I would have an r and an h, which means I'm going to get a rate of change for r and I'm going to have the rate of change for h. They don't give me dr dt, right? They're not giving me dr dt. So if I can, okay, which thankfully I can, I want to get this all in terms of h, because then if I take the derivative, I'm just going to have dh dt and I'll be able to find it, okay? So how do I do that? Well, they gave me some really crucial information over here. They said that the radius was 2, the height was 6. So if I were to draw another, so now, first of all, notice if I connected this, that's a right triangle. Okay, and if I were to draw another one where these are parallel, right? And these are parallel. This is my R, this is my H, then I'm going to have similar triangles. Remember how we did all of that similar triangles? Remember with in CPM where
I
we
think so.
enlarged things, and it's like, as long as if these are parallel, then they're going to be similar triangles, which means I can set up,
Oh, yeah.
yeah, I can set up corresponding sides. Okay, so I could say R over 2, so I could go R over 2 is going to be equal to H over 6. Let me move that over a little bit, okay? And then I can now solve this for R by multiplying both sides by 2. So let's do that. So R basically becomes 2h over 6, which is h over 3. Okay. Now, if they had given me this problem and let's say they had given me dr dt, let's say they hadn't given me, dh dt, they gave me dr dt, then maybe I'd want to solve this for, I'd want to solve it instead for h, right? So that I could put, so I could have this all in terms of R. Does that make sense? A little
Yeah.
bit? Okay. But I'm going to do that. So now I'm going to go ahead and substitute this, okay, for the R. So let me just rewrite. So I still haven't found the derivative yet. I'm getting closer though. Okay. So I'm going to just multiply these across. So that's going to be pi over 3. This is going to be h over 3 squared times an h over 1. Okay, now if I was maybe doing this myself, I probably would have just put this down as h squared over 9. But I kind of want you to see, everything that's happening. Okay. Okay, so again, I'm just going to simplify that a little bit. So this would become h squared over 9. And then h squared over 9, I will multiply across. So I'm going to end up having, basically, I'm going to have a 9 times 3, which is going to be 27. So I'm going to have pi over 27. H squared times h would be h cubed. Okay. Are you following?
Yeah.
Okay, now after all of that laborious work, okay, now we are finally ready to take the derivative, thankfully. Okay, so the derivative of the volume going in would just be dv dt, right?
Yep.
But with the in. Okay, the derivative of the volume going out will just be dv out over dt. And now notice, right, this is actually a lot easier to take the derivative, because if I'd left it r squared h, I would have had product rule and it, would have been more complicated. So this is a simple one. The 3 comes in front. So I'm going to have 3 pi over 27 h squared times its derivative, which is dh dt. Okay. Now I just need to go ahead and substitute in, right, the things that I know. So this is 10,000. So I'm going to go ahead and write, so I'm going to have dv of the rate of change of the volume in, this is minus 10,000 equals, I'm going to just simplify this because that's going to be pi over 9. So I have pi over 9. My h was 200 squared, and my dh dt was 20. Okay. Last thing I need to do is just add this to the other side. Okay. So I would, at this point, I would grab my calculator. Okay. And I would go and say, okay, I'm going to do 200 squared first and hit enter. I'm going to times it by 20, hit enter. Okay, I'm going to times that by pi. And I didn't have to hit enter with all of those. And then last thing I'm going to do is divide that by the 9. Okay, so now I have that. And then, so that's this. And then I just need to add the 10,000 to it. And I'm getting that pretty big number. So I'm going to put, so that's going to be 0.680. And that's my dv dt. And I don't want to forget the rates. So that again is centimeters cubed per minute. Okay. And it makes sense that this rate is larger than the other rate. Okay. So if I got this and let's say it was like negative or something, or, or I got it and it was less than the 10,000, I might want to go, I maybe made a mistake somewhere.
Yeah.
But okay. All right. I hope that that helped a little bit. How is Matt? How is Matt, by the way?
Doing pretty good as far as I can tell.
Okay, because you're friends with him, right?
Yeah, we played a little bit of games yesterday, so he's not like missing or anything.
Okay. Well, I don't have him. I don't have him this year. So,
Yeah,
and then obviously I can't see him because I don't have him,
exactly. Yeah.
But all right, I will stop that video. Oh, wait, I didn't mean to do that. All right. Let me, that's what I meant to do.